My name's Charles Edler. Welcome to my Physics 2 Lab 2 Charge Tapes Revisited. So the purpose, concepts, and formulas are pretty similar to the first lab. The only thing that really changed in this lab was the code. But the same purpose is to find the excess charge of one clear piece of tape. This charge is created with two different tapes ripping apart, and we're just seeing the results of them. With no Coulomb's law, stuff about electric fields, which is just point charge in the rod of E. Point charge was with the first lab. Now the rod of E is for this lab because now we're imagining the charge is separated uniformly between the whole piece of tape rather than just one point. We know stuff like the force of gravity as well, and then these are just K constant and the charge of an electron are the same as well. We had to do this up as well in our calculation for the uniform charge. The length of tape was 0.2 meters and the width was 0.019 meters. The mass is around 0.0002 kg. And the measured distance between the two tapes when A was interacting with B was 0.004 meters. Now the results are different from the first lab. The charge of the electron now doing the uniform is 5.903 to the 10 to the negative 9 C, and the magnitude of gravitational and magnitude of the electric force are exact same as before. And so when we're calculating the new charge now, because Fe and Fg cancel each other out, so they equal one another, and now the F electric has a different formula, but it still gives you the same result. So the left side is the exact same with 0.002 times 9.8 for the mass times gravity. The right side is the K constant, 9 times 10 to the ninth, times the charge squared. All that is divided by R, which is 0.004, which is just the distance separating between A and B, times the square root of R squared divided by times the length divided by 2 squared. And that ends up giving you 5.903 times 10 to the negative 9C, just like before. Now we have a lot of coding right here. So look at the top left, which is the mass of the tape, and then a resulting charge. My data is inaccurate because my charge at the first lab was 1.167 to the negative 9, but to allow the actual result of the code to look properly, we had to change it. So now it's 3.867 times 10 to the negative 8. So that's just one error in my code. But other than that, everything follows exact same. The right, exact same as the first code, just define the E field with charge particle and observation location. The E scale and the Fe scale are 2 times 10 to the negative 6 and 80 respectively. Those are just based off how we want the size of the errors to look, so it's more of a guessing matter. And then as we just go down, it's pretty similar to the last code. Yeah, and this is what the resulting picture looks like. We can see that the electric and gravitational are very, very close to each other. They're supposed to be exactly equal, but that small difference doesn't really matter as much. It's such a small number in general. But we can see this how the code is supposed to look like. That's why the scales were different. Some assumptions we had to make during this lab. We had to ignore air resistance. This one we did not. Instead of this lab, we treated it as a uniform charge, but the first lab we treated it as a point charge. So that's one assumption we're changing from the first lab. And then, but one thing we're also assuming is that it's the same amount of charge evenly distributed around the tape, like I said before. So what if and why? What if you model each of your tapes as a single point charge like the previous lab? So this is what I was talking about before the changes. So lab 1 was a point charge where we got 1.867 times 10 to the negative 9. However, this one we did a uniform charge, so it was 5.903 times 10 to the negative 9. And why do these numbers differ? And which one is more likely to be close to the real value? Lab 2 is to be close to the real value because with a whole piece of tape, it isn't really a point charge. Everything is distributed out. And so lab 2 would be the more accurate measurement of that since it's actually measuring for the whole piece of tape rather than just one point. Thank you.